All right, hey, Dr. Green. My name is Gavin Stieber,
Benjamin Abu.
Corey Miles.
and this is our attempt at a Stirling engine for the honors contract for Thermodynamics.
So I'm going to be talking about the design of our Stirling engine. So to get started, we used this tomato paste can as our system. It's relatively small, so we thought it would be good for our displacer, the steel wool right here. The steel wool fit in there pretty nicely. What the displacer is there for is to go up and down to make the air go from hot to cold within our system. We used these popsicle sticks to help connect to the crab shank right here. We also used this balloon as the diaphragm so that it could expand as the volume increased and then decreased. We have a little crab shank right here, which is connected to, we had a little wheel right here that we spun, which would be the Play-Doh lids. And then as that was spinning, the crab shank right here would go up and then bring the balloon up and the displacer up as it's connected with this little string wire right here. And then that would create our engine and our system. We also use these cups right here to help keep this crab shank at a good little level. What we did is we lifted this up and then put a candle underneath it so that it would be heating it up. So thermodynamically, what we had as our system was the tomato paste can. Inside of that can we had a displacer, or the steel wool. Connecting the steel wool to the crankshaft up here was this piece of string right here. So what we did is we put a candle and we lit it, which created heat into the system underneath it. So the heat came up and heated up the air within the can. So the hot air was on the bottom. And once it started to heat up and we got the hot air on the bottom, that meant that there was cold air also at the top that was a different temperature from the bottom. And as we learned in thermodynamics, it wants to go from hot to cold. So what we did was we moved the crankshaft. And while moving the crankshaft, there's work in there that moved that displacer and then moved the hot air to the cold air. And as this was rotating and the work was going into it, the air just kept circulating throughout, going from hot to cold, hot to cold.
You want me to give it a talk? I think there's definitely something too hard. I think there's just too much resistance in every single piece of this, like the balloon, the sticks, the crankshaft,
Yeah, I think so too.
because it's pretty hard just to move it on our own. Plus we have the crankshaft that's moving. And I think the pop-up isn't even from the pressure inside, it's just the balloon pushing back up on the stick.
It looks like there is a lot of resistance and it's not big enough, so we might need a bigger balloon so that it creates more room to actually turn around. The crankshaft right here, it's pretty big in the turns. We might need to minimize that to like half the size.
Yeah, and then overall just the base is pretty janky and it wasn't very stable, and so a lot of the examples we were looking at, they had like a nice like 2x4 built out box that could hold everything together nicely.
I don't know. Don't you think that this has maybe a wider base, or if the cylinder is kind of a little bit bigger? I don't know.
Yeah, having a larger can would probably help
Yeah.
because
the evenly distributed, it's kind of.
yeah, like the size of the can that we're using, like you can see like when we pull up on these, it wants to pull the entire can up. So
Yeah.
that's also another problem that's going on with this.
Yeah.
Yeah, and then also I noticed there was a lot of resistance with the plug that we were using to move the pressure for the work piston. on top, and so that could be another problem where it's resistance when it's pulling up and down on the inside of the can.
Overall, the experiment and the project really helped us learn a lot about thermodynamics. Mostly how difficult it is just to create a simple engine out of just homemade things. Um, there really is more than just theory going into the engineering behind this. Also, I believe that it helped us bringing together not only our thermodynamics but our heat and mass classes. So that was very interesting to learn about. It was also interesting to work on a project with engineering. This is the first major project that we've done with groups. Most of it's just been theory based up to this point. So that was very exciting. One thing that I would change is I would maybe invest more money into better materials, or within the entire year or semester, try different designs and see which one works best. But all in all, it was a pretty fun project. Definitely learned a lot, and I think future students would definitely benefit from this project.